This panel is with us this morning. We have about an hour, so we have a good amount of time to explore what's actually happening with some of the next-gen implementation and other issues. I may throw the panel a little bit of a curve, but they're up to it. First, I want to do a quick introduction. Ginger Evans is from Chicago. She is a commissioner managing and overseeing one of the world's busiest airport systems, O'Hare and Midway. It's just unbelievable. 90 million passengers, over 1 million operations, 1.5 million tons of cargo a year going through this airport. So these airports. So vital role in next-gen implementation. Airports, well represented. Tracy Lee, somebody I have the pleasure of serving with on a variety of committees, Vice President, Network Operations, United Airlines. Tracy, I hit FlightAware the other day and looked at, for some reason, I'll explain why in a minute later, but for some reason looked at all the United Airlines aircraft in the air over the United States, actually over around the world at one time, and it's unbelievable. So I don't know how you can sit here for an hour with us, but thank you for being here. Of course, my very good friend, Mark Baker, who's the president and CEO of the Aircraft Owners and Pilots Association, representing close to 400,000 individuals who fly private aircraft, business aircraft, fly commercial aircraft for that matter, but pilots and aviation enthusiasts, a very, very exciting group, as he knows only too well sometimes, but Mark has done a wonderful job both leading this organization here in the United States. He also leads an international group of general aviation under the AOPA name as well. Mark, we're very, very pleased to have you with us. Carl D'Alessandro from Harris Corporation. This is a company we all need to know a lot about because when you think of the underpinnings of our air traffic management system, Harris is right in the middle of that, developing some incredibly great technology, not only for this country, but around the world. So, Carl, thank you for being here. Craig Drew, a guy's name I'm not going to forget. Craig at Southwest Airlines has been involved there for some period of time, a fellow pilot, moved through the ranks in the right seat, left seat, and then into management. It probably still flies, I don't know.
A little bit.
That's good. But obviously Southwest is dominant in so many parts of the country, and very pleased to have you here to talk about our development. And last, but certainly not least in this listing, is Jim Eck. Jim is with the FAA. I want to get the title right. Assistant Administrator for NextGen. Jim has been at the heart of literally everything we're going to be talking about for the next 2 days for some period of time, and is a great source of wonderful information. What I wanted to do when I said I was going to throw you a little bit of a curve was I got to thinking about the people on this panel in the last 3 decades. I don't want to spend an inordinate amount of time doing this, but with so many things flying around Washington, policy-wise anyway, about air traffic control and air traffic management, I thought it would be interesting for some of us to at least share our perspectives on the 3 decades. You know, so I was around a long time ago in the Reagan administration. President Reagan had this notion, with some opposition, frankly, from the Secretary of Defense, that the global positioning satellite system that the government had developed, launched, and was utilizing should be made available for commercial operation. This was in the mid-'80s. And once he did that, there were 2 fellows, first name of one was Min, second name one was Gary. They got it in their heads in the late 80s that this changed everything, that no longer would we be flying airplanes from VOR to VOR, maybe a fix created off the VOR, that we would instead be using the global positioning satellites to do it. Initially, the industry said, no, that's not going to work. We've got too much invested in the system we're using. So these 2 guys left, Min and Gary, or Gary and Min, and they formed this little company called Garmin in about 1989. And that in my mind, in some ways, when we talk about modernizing the air transportation system, that's when a whole lot changed. Because, we're getting to the quiz, because in the early 90s, those of us who were flying airplanes in general aviation could begin to bring a handheld device into our cockpit. That Mark Baker remembers that. And suddenly we were able to do what? Fly point to point. Pretty soon, see a moving map. Pretty soon, talk to the controllers and ask them to go point to point, even though we were that second point was well beyond where a VOR signal might be found. So when you hear the debate that pilots like GPS, we do. We've been using it since the 90s. And Craig, you were flying in the 90s, right? Mm-hmm. The airlines, and in no way criticism, have a huge investment in their avionics, saw this happening, and began converting the fleets, right? 90s, early 2000s?
Late 90s for Southwest.
A single-engine piston plane that I bought in 2003 had a beautiful Garmin moving map, pretty much everything in the plane on that. Now that's just sort of a given. A little two-seater Husky I flew had a little Garmin unit moving map. So pilots in the aviation community have been able to do that for a long time. And at airports, back in the 90s, we were lining up for a ILS approach. Everything was based on something coming from the ground to our airplane, but now we use GPS. The aircraft have flight management systems that get GPS and VORs and other navigational information. So they're using all of that to fly these new arrivals and new approaches that are going into Chicago and Midway and better separate aircraft. So my point is that this has been a process that has taken time, but really moved in some ways fairly rapidly, especially when you have big investments that you have to make in these systems. So I guess to start, I'm going to go down here and let you all talk. Mark, maybe I'll start with you because we know each other well. But how have you made that transition? How's your flying changed over this period of time as things have modernized?
Well, you're right, Craig. It really is a wonderful world today with GPS. All the little airplanes to the jets that I fly. The Direct 2 is the most often routed location. I flew yesterday from Minneapolis to Frederick, and it was basically cleared to Frederick direct just after leaving Minneapolis. And that kind of navigation, if you'd have tried to even imagine it 25 years ago, when you were so happy to come off of dot, dash, dot, dash, dot, to Loran, to RNAV, to what is now today GPS. It's an amazing technology advance. It's really occurred in a relatively short period of time, 25 years. And it is, no way would we want to go backward. And then you throw the iPad in the cockpit where you have situational awareness for $700, $800. It's incredible what the information you have from weather, traffic, all those kind of things now at your fingertips in every type of aircraft. So it's an amazing forward, and I think that the system actually works pretty well today. As I've mentioned before, with hundreds and hundreds of thousands of flyers and owner-operators, we don't get any complaints about ATC from what is a very large user of the system.
So, Carl, maybe let me come to you next. Harris has gone through different changes, but the technologies that you've been deploying have taken us through this process. Talk about some of the underpinnings that you all have both provided and are providing as we move into this more modern air traffic control system.
So this room is probably about the size of the room that we installed the first en route voice switch. And when I walk around an air route traffic control center today, I'm struck by how empty they are. And they're empty because the technology has just gotten to the point where you don't need all that physical space. I read last night on the plane GAO report, June 4th, 1980, complaining about how we can't get the conflict probe to work because there's not enough memory in the computer. And of course, we don't have those issues anymore. And the technology over 30 years is a good benchmark, right? I started about 30 years in this business. And the technology is really advanced to the place where you can start doing some remarkable things. We talk about GPS and just the computing power and the technology that's available to implement what's needed from a procedural and process perspective. Remarkable.
Ginger, the airport environment has certainly changed over this time period. How have you seen changes at O'Hare and at Midway in the last decade or so?
Well, the airfields themselves are an important part of the NAS, of course, along with the airspace. And when I was working as a civil engineer, the controllers used to call them sticks. Give me another stick, give me another runway. And there has been a big push, of course, in the last 20 years to not just build new runways, but build them better. I was thinking back to the days when we actually did the first triple IFR approach at Denver International and we did it on opening day, the first arrival. We did triples, and that, even though it was ground-based radar, we were only able to do that because of the availability of a PRM. They had done the trials in Raleigh, and we said we got to have it because it was better, faster data for the controllers and the pilots. So that combination of the technology, the collaboration, the real-time information is what made that incremental jump from the long-standing procedures possible. And we showed that we could reduce spacing in IFR conditions safely as long as the pilots had that information and the controllers could monitor any deviations. So each one of those incremental gains has given us a path to the next incremental gain. But wider space runways and the ability to instrument them properly, weather detection, all kinds of things on the ground that make talking to the satellites possible.
Ginger, you made a really important point I want to emphasize too when you talked about collaboration, because there's no question that this technology is phenomenal and it's at the heart of all that we're talking about, but it's not just technology, because technology without training, without collaboration, without consensus around how to utilize it, doesn't get us where we want to go. So doing what you're able to do with the incredible number of operations at O'Hare and at Midway, even deconflicting flights, wouldn't happen without a lot of a human experience. Oh, yeah. Tracy, so I have to tell you, I flew last week.
Oh boy.
I had four United flight operations. To make a dinner, I had to connect in Chicago. So United Dulles to Chicago, Chicago to Portland, Oregon, and then coming back, Portland to Denver, Denver to Washington. Tracy, only one of those flights was on time, arrived on schedule. The other three arrived early,
all right,
ahead of schedule. Remarkably, I'm not making this up, remarkably, so 4 operations, every aircraft pushed back, taxied for takeoff, moved onto the runway without pausing and departed, landed, taxied without stopping to its gate. 4 for 4. So we talk about collaboration, the surface management, the flight planning. In fact, you know better than me, but arriving early sometimes is even a bigger challenge because the gate isn't ready. Everything was ready. And I do read some of the quarterly statements from the airlines, and I see more on-time flights, more passengers carried. Really pretty good story. Mm-hmm. So how have operations evolved to get this kind of, I know everybody has a bad story to tell, but I have to tell you, now that I fly more commercial flights, most of mine are positive. What's the evolution been to get you where you are today?
Well, thanks, Craig. You started this by talking about 3 decades, and it's interesting because I had my 30-year anniversary at United just a couple months ago. So we talk about the transformation that's occurred in the industry over time, and clearly that's had a huge impact on safety, and that alone is enough to justify everything that we're doing. But beyond that, you think about what are we trying to achieve, and it's things like increased reliability, predictability, and efficiency. And one of the things that I'm really excited about that we've been able to make some progress on this year is kind of trying to say, okay, of those things, which are the most important? And I certainly won't say it's unanimous, but I think there's a growing consensus that reliability trumps efficiency in the near term. If I can improve the number of customers who are arriving on time, that's more important than saving a few gallons of gas in the near term. Certainly we want everything, and a lot of these things are positively correlated, and so that works great, everybody wins. But when you have to make a choice, I think reliability is the most important thing to pursue.
Interesting. Wow, 30 years. Man. Okay, Craig, Southwest Airlines. Southwest, all kinds of interesting records and all kinds of notoriety. You were an early investor at Southwest in some of the technology. But take us back to the 90s, because I'm interested in, especially from a person who was in that left seat as a commercial pilot, how you've seen this sort of next generation technology evolve.
Well, let me take it back 30 years.
Okay.
Over 30 years ago, I got my first flying job up in British Columbia, Canada, flying Bush one summer. Does anybody here know what a range approach is? You know what a range approach is. That's an approach that they used decades ago. And they used the old FM station, and they used the A and the N signal. And I forget, one was a dot and a dash. And when there was a hum, you were on course. You didn't even have a needle. And that's how you flew. So I got to fly the last range approach in Canada, which was back in 1980. You jump forward today and you look at the incredible advancements which we made, and it really is impressive when you look at all of the new technology. You look at RMP and GPS and all those things. So when I got hired at Southwest in 1990, I was hired by John Tree. Where's John at? Over here, raise your hand. He was the chief pilot back then in Phoenix. And we had the old 737-200, and it was a basic airplane with very basic instruments. I used to call them Cessna 150 instruments at the time. And that's what it was. It was just very straightforward, and for the time, it worked very, very well for us. But as things advanced, Southwest didn't come along as quickly as some of the other carriers did. When we bought the 737-300, we actually dumbed it down so it would look like a 200. And then when we bought the 700, we wanted it to look like a 300. That's all now behind us. I want you to know that on September the 30th, we will be retiring our last 24 737-300s, and we will have a 100% next-gen fleet with the 800, 700, and the MAX. So we're excited about that. So we've come a long way since then.
You have. And now you mentioned this, so I'm going to get to my friend Jim here in a minute. But so what is a sort of next-gen fleet? What do you see as the kind of the complete package now in these aircraft?
Well, I think it's important that you can operate that airplane within a system that provides all the support necessary for it.
Okay.
And we're starting to see some of those things. I think you look at Datacom, that has come a long way. We're excited about that. I was discouraged to hear last night that it's going to be put off for another 2 years in the en route portion. I would hope that wouldn't happen. So some of you, if you want to make your around the way visit to your congressman, please do that to make it happen. When you look at the air traffic system itself, as you know, I mean, I'll just go right out and say Southwest Airlines is very interested in reform. Now, whether that happens like a Canadian system or an English system, who knows? One of the things to consider, though, is that the complexity here in the United States is 10 times greater than what it is in Canada.
Right.
That doesn't mean we can't do it. But I compare it to back at Southwest Airlines when we had 75 airplanes. We were very nimble. We were able to turn on a dime. Now with almost 750 aircraft, it takes a lot more time to turn that ship around. Sure. It's more like an aircraft carrier.
You've introduced some topics I want us to get to, and maybe we'll probe a little bit more about. Jim, so take us back to the 90s. Where were you at the FAA? What were you involved in then?
I was working on a thing called NextCom, as opposed to NextGen.
Right.
But going back then, and you bring up GPS, and I listened everybody's story about the sort of how that technology has made a significant difference. But in almost every case, it's made a significant tactical difference, and a big one, no doubt about it. But what Tracy said was he wanted to get to reliability, and ultimately that to me would mean network reliability, and therefore strategic reliability, and not simply just tactical efficiency. And a lot of the things that we're putting in place now are going to contribute to that. A ubiquitous ADS-B system where we can track you wherever you are, a swim capability that is going to exchange all kinds of information about the system on almost every aspect of the system, from weather to the configuration of the airports to where are we with the airspace in terms of its capabilities, to the datacom program itself that will not only allow a pilot and controller to communicate rapidly, but any pilot can connect to any controller in the future because it's networked. Carl brought up the voice system. The other thing about that voice system that took up a room full of processing power was that it was hardwired to a particular set of radios, and so you could only talk from this seat to that piece of sky over there, and that was it. The new system that's coming out is going to be a fully networked capability, so the ability to exchange information rapidly and among anybody who wants to talk is now going to be possible. So everything that we're putting in place as the platform called NextGen is about opening up the system to make sure that information can go where it needs to go and when it needs to go there. The challenge, of course, for us is how are we going to use that information? What's going to change so that we can use the information to do exactly what Tracy suggested, which is to get greater reliability in the system. And it strikes me, going back almost 40 years, the parallel I think about is, I know when I showed up on day one, there was a typing pool, and you hand wrote out what you were doing, and you took it down to the typing pool, and then they typed it up for you, and they made a certain number of copies, and that was it. And then along came a thing called the word processor, and a company called Wang made a lot of money selling a word processor. And then along came PCs, and everybody got a PC on their desk, and now we could type away as much as we wanted. But a funny thing happened. They kept measuring productivity in the industry, and it went up maybe 1% a year over almost a 15-year period. And CEOs everywhere were complaining that they were spending $1 gazillion on an IT infrastructure, and nothing was changing in terms of productivity until all of a sudden communication networks came into being. And now we could not only type things up, but we could transfer them back and forth, and then we could transfer more than just word processing files. We could transfer spreadsheets, and we could transfer all kinds of batch data, and that lots of information. And suddenly, productivity in the mid to late 90s in the industry went through the roof. And it was all about the change over from individuals looking at their sheet of paper and what they needed to do that day, and then handing it off to the next person so that they could do something with it, to now we could rapidly exchange information. And the very nature of what we did changed as a result of doing that. And I think that's right about where we are with NextGen. We're putting all kinds of technologies in place that's going to enable lots of opportunities for us. And are we going to be smart enough as an industry and as a community to say, what's the best way to use all this information now that we have it available to us? And I think that's been the evolution that I've seen coming through.
Well, I want to also give you credit, because it's not only the evolution you've seen, but I know from my experience, you've also been an architect, and you've been a believer in this. The downside, if there is one, I'm not sure how else you could approach it, is that you couldn't, in your example, you couldn't have the exchanges going on until you had that infrastructure, those systems in place. And I think maybe some of us, when we first started talking about modernization and NextGen, there was this feeling that either a switch was going to get flipped and it would all be great and different, or there'd be big gains right from the start. And that's not really that's not really probably possible, I think. I don't want to put words in your mouth, but I think you've been laying the groundwork, and we've been seeing some benefits. We've all changed the way we fly, but you're suggesting, I think, that there's not only more to come, there's much more to come if we're smart about how we use this.
I think so. And I think you're right. Even, going back to the beginning of NextGen, when the aviation community got together, everybody wanted a transformation. Everybody admitted that continuing to do the same thing the same way and try to do it a little faster wasn't really going to change much about how aviation, how everybody was flying and how they were using the system, and we would have tremendous limitations as a result of that. But to get to that transformation, which is really an operational change, there had to be an underpinning of capability, and we had to make sure that the automation that we were building at the time was going to be flexible and robust enough to handle all of that. And that included ERAMs and the STARS platform for terminal and the TFM platform that was still in its infancy and still evolving today. We've built other platforms like TBFM along the way, and now recently with the TFDM platform coming into the terminal environment, we think we've got the computational power in place with all of the other programs that we built on top of that, the CommNav and surveillance programs in place. We think we're at a point now where we can, as a community now, say, okay, what's this transformation we really want? We think we have a pretty good idea of what we want, but now it's time for us to all sort of agree on, okay, is that the very thing that we want now?
Right. Carl, let me come back to you for a minute, because we've talked kind of aircraft-centric, at least partly. Jim's helped us think about what some of the computational possibilities are. But at the heart of this, in my way of thinking, just my way of thinking, those of us who flew and began to embrace GPS in the 90s gave ourselves in the cockpit the ability to know with great precision exactly where we were. And then the systems got better in the cockpit, where you could actually estimate with great accuracy where you're going to be in 30 minutes, an hour. You could winds, all the things that again we almost take for granted, but GPS does for the pilot in the cockpit. ADS-B, it seems to me, now is a means of giving the controller more accurate information. But for that to happen, we needed an infrastructure. And we have a ground infrastructure, which I think you should talk about, because that's actually a very good story of something being executed by private sector on behalf of the government. But then I also want to ask you, just so you know, a little bit about the satellite infrastructure too that's going up. But tell us a little bit about how you look at ADS-B and what you believe it can do for the future that Jim is talking to us about.
They're waiting. So, I mean, we've built out the infrastructure, and to Jim's point, we now have the computational capability. We're on new platforms, so we have very accurate positional data for aircraft that are equipped. We can see them, and mirroring the capability that you mentioned in the cockpit, we have that now on the ground. And to Jim's point, where do we go next? How do we think about air traffic control strategically? So that's traffic flow and some of the things that are coming online. But I would agree. I think that is actually kind of a good news story. The infrastructure is in place. I saw an infographic from testimony last week. There are true successes as far as the infrastructure, communications, navigation, surveillance, and the automation underpinnings for all of that. So I think it's in place now. We have a ground ADS-B system. We're talking about satellite-based for where there's not ground coverage. And those discussions are going on, but I think from an infrastructure perspective, we're in good shape. And now it's how do we, and the infographic showed the next phases of NextGen, and so how do we bring out more capabilities? How do we incorporate aircraft and systems and procedures to take benefit of this infrastructure that's in place?
So maybe, Tracy and Ginger, when you talk about what you're able to do in Chicago, you can't have that many operations with the asphalt you have without simultaneous arrivals and departures. This kind of technology gives you the ability to improve on that, to enhance on that, right? Not in the cockpit yet, or coming, ADS-B. Some in your...
It's coming. At United, out of our 730 airplanes, I believe we have about 300 equipped so far, and we're on the path to be complete by June of 2019. I think one of the benefits that I would hope to achieve from this is decreasing the variance of actual flight times. And there's a ton of leverage associated with that. To the extent we're able to do that, or let me say it another way, the variance of actual flight times has grown over time, and as a result, airlines have been forced to add scheduled block time to capture more of that bell curve. And it's not a nefarious plot to make on-time performance figures look higher. It's just a natural consequence of a flatter bell curve. And so if we can pull that in and make it tighter, then we can reduce those scheduled block times. And when you do that, you're creating airplanes out of thin air. So then you can grow and then take advantage of the capacity benefit. So it's a virtuous cycle.
Well, in our most crowded areas, in Chicago, Northeast, it really is looking to the future. You have a whole community in Chicago that wants to see capabilities at the airport to sustain economic growth on the ground. It's not just wishful thinking. How are you going to accommodate more operations in Chicago?
Well, we're adding more sticks. We're building a new 11,245-foot runway right now. That'll give us 2 very long runways, 8 in total. We cannot convert to RNAV procedures until that runway is complete in 2020. We are RNAV at Midway. But basically, we've already seen some of the benefits. We were one of the beneficiaries of Datacom last fall. And so, components of it are coming online, even though we can't do the whole system. But, I would just reinforce what Tracy's saying about reliability. By the way, that's what passengers want too. Passengers want that reliability. They want to know what the deal is, predictability. And if it's 5 more minutes, fine, but just tell me what the deal is. So I think that's a broad consensus around that term reliability, system reliability, schedule reliability. But one important aspect for our community, the economic benefits are well established for aviation, for us as a nation. But one of the benefits, of course, we want to see is the noise benefits. Right. We absolutely want to use these tools to take approach of curvilinear approaches, optimized profile descent, for the benefit of being able to have these precise routings that will have noise benefits to our community and higher altitudes on approach. So we can't wait to get to that point. And let's not forget, that is a real benefit that isn't talked about enough. So once we've got the tools, I'm confident based on the collaboration we've had with our users over time that we will be able to successfully do that.
Ginger's exactly right. The reason reliability is at the forefront is because that's what customers want. Right. When you look at customer satisfaction data, on-time performance kind of dwarfs everything else. Customers want to get to their destination, and they want to get to their destination at the scheduled arrival time or earlier. And if we can satisfy that, then in large part, they're satisfied.
Craig, you agree with that?
Yes,
on the importance of reliability?
I do want to say
Ginger
something
wanted
else.
To drive us to agreement on something, so I'm hoping this might be it.
What I wanted to add, though, NextGen is wonderful. We can build these 16-lane highways in the sky going 150 miles an hour, but if we only have one exit and we only have one small parking lot, it's not going to work. Right. So the infrastructure also has to grow. We need bigger airports. We need more runways, more taxiways, more ramp space, more gates, et cetera.
So I think you agree with that, but you also are all working on surface management, which I actually didn't know a lot about until a few years ago. I still only know a little bit, but I think that's, it's in some of these areas, we heard about the Northeast, it's just putting in more runways is going to be a challenge, but managing what happens on the surface, I think is what, sends me from the gate to the runway without stopping as opposed to being in the long lineups. And that's an exciting opportunity too for it.
It is. I mean, LaGuardia will have the same number of gates when they're finished as they do now, but with wider taxi lanes, they'll at least be able to push back independently and reduce some of the dependencies. So using what you have and making it more efficient, they're basically using the space that used to be a parking lot to do that. Right. It's expensive. So you're going to have to replace that parking lot in part with a train. Guess what? It doesn't matter. You have to do it. You absolutely have to do it. And making best use of the real estate that we have is exactly the path we have to do. It is expensive. We are getting rid of 2 very old, 50-year-old pieces of pavement at O'Hare to get geometry that's more rational for pilots, as some de-icing pads. So with moving those taxiways, we've created 400 acres of developable real estate at O'Hare. Who has 400 acres of developable real estate at a major North American airport? So we'll be able to do a lot with that 400 acres, Craig.
And you look at Midway Airport as an example. It is 1 square mile. We've got 240 flights a day out of there. You have business aircraft, you have private aircraft in 1 square mile. And so it's actually working very well there for us. And you compare that to, say, Denver International, it's what, 54 square miles of space.
But of course, it's not just that surface,
Exactly.
it's also deconflicting
Exactly.
arrivals and departures.
Exactly.
Jim had a point, and then I want to come to Mark.
That was the very point I was going to make, and one of the challenges we have, right? Craig points out we can't just make en route really efficient, and then we can't just make the airport surface really efficient, because now we've got a terminal airspace block that becomes the problem. So you can't work in every airspace simultaneously every single day. We sort of have to logically work our way through, or at least just as a community consensus agreement about where do we work right now. And because getting all kinds of great efficiency at an airspace level or at a surface level, or a particular surface or a particular airspace, that's interesting and it's helpful, but it isn't going to move the needle on the entire system capability. And so that is one of our challenges. We've got to be sure as a community we understand that too. And I know maybe we'll talk about metrics and measures, one of my favorite topics along this thing. We'll hold on to that.
I'm going to get to that.
Okay.
We're going to have a big finish on that one.
All right.
So Mark, it is the case that the airlines use about 400 plus airports around the nation, but we have 5,000 public use airports. And some people used to say to me, well, obviously that shouldn't be a problem, except of course, pilots actually like to fly to these same metroplex areas. Yes, a lot of us like to fly in the west and the mountains, but still most of the operations, especially business operations, are into these in these metroplex areas. So how, when you look at your private pilots, your business aviation members, how are they looking at NextGen? How are they, what do they see coming at them? And some of the aircraft are among the most sophisticated in the world, really.
It's certainly clear that ADS-B is where most aviation, general aviation people are going to be touching NextGen. And there's some real challenges on the rollout of that equipment. There's probably 20,000 of the general aviation aircraft of the 160 or 70,000 that we kind of keep on the registry. But there are some challenges that we'd like to see them all equipped, because if traffic's going to be really a value for the whole NAS, you'd like to have 99% of all aircraft equipped, and eventually figuring out what that might mean for the drone makes it really important for us to ultimately have a very high percentage of the fleet adopted. And while there was a good attempt with the FAA to do a rebate and get that to be a $500 per aircraft kind of rebate, it expires here in September, the market view is in. There's maybe about 7,000 that kind of get done through that. I think the allocation was for about 20,000. But some of the rules that were, again, well-intended, where if you lived in Montana, you had to go fly to ruled airspace to get the rebate, which could mean a cross-country of 500 miles to go get a $500 rebate. The market has kind of suggested this isn't working. I think we have to take another view about what is it going to take to get, so we have 100 to 150,000 of these general aviation aircraft equipped. I think there's also a challenge in some of the older turboprops and older jets that many of our business customers use. They'd either have no pathways for an ADS-B equipment yet, or maybe $50,000 or $80,000 an aircraft that maybe have $500,000 value. So there's still a lot to be figured out. I think from the the raw purist that says I'm going to do an ADS-B out, what did I get? There's still that challenge. We're still encouraging, and it's been a lot of time in media to tell people there's good things here. If you do the in and out, you get traffic and weather for free, which is a great value for those that actually use their aircraft for transportation. There's good value. For those that are just using it for recreation, what's the value and what's the cost relative to a $30,000 airplane at $3,000 or $4,000? That's where the challenge still remains. So I see part of the group adopting and moving forward, and I see another risk here that if we don't get all of them, we're not going to have the results we're looking for.
Good point. You know, we heard from our current NAC chairman about if we're not doing NextGen in the Northeast, what are we doing? And I guess I'd like you to, each of us from your perspective, help us with that a little bit. You know, for the sake of argumentation, not to be just provocative, I think that at least my flying experience, when there are delays, most of the time it's the weather. Sometimes further complicated by scheduling, and I understand why you want to get as many commercial flights in and out of an airport as possible, but if things back up, in the Northeast it backs up real fast. So if weather and scheduling, if you agree, you don't have to, but if you agree that's a big part of the delay factor, what do you think we can realistically do? I think maybe, Carl, I'm going to start with you. All these guys think, because they're kind of on the spot. What can we realistically do with technology and collaboration to realize this ambitious goal that the NAC chairman's laid out to begin to improve the operations in the Northeast?
Thank you for that question. Just from an infrastructure and technology perspective, first off, I would say, just the simple fact of, making it a priority and focusing on it is helpful. It's been an issue, and it's been an issue forever. It's been talked about for 30 years, and so having the NextGen Advisory Committee and the power behind it, and the workforce behind that, focusing on it, I think will bring value. I'll just, something I know about, data interchange and SWIM, and, leveraging some of the surface work that has been done more broadly in the NAC and applying that to the very constrained airspace, very busy airports, and knowing what's going on there, I think could be helpful.
Is that for you or Jim? Is the technology underpinning infrastructure? Is it in place? Is it coming along at the same rate as other areas? Jim, I think, might be.
So I'd say it's coming, and in some cases it's already there. We've got a lot of tools that I think we can bring to the Northeast Corridor. Probably not going to solve every problem on day one, because I think what we're going to look at in the Northeast Corridor, and I don't want to presume the answers that we're going to get back from the subcommittee, but we've talked about it a number of times, that and going into the Northeast Corridor and keeping the tradition of sort of the discussion at the NAC level about trying to take IFR performance and moving it up to VFR performance. That's really what we're going to try to do there, right? Which is, we know we have some pretty bad days in the Northeast Corridor based on weather and based on other constraints in the system. Can we know better about the instant status of everything going on? Can we understand the constraints better? Can we predict when they're going to appear and when they're going to disappear better, so that we can actually schedule around them better? All those things, I think, are going to be possible here in a very short period of time, and play into the kind of solutions that we can provide there from a technological point of view. I think the group's also looking, though, at just even procedural things that could be done differently right here and now with the equipage we've got and the capabilities we have on the ground, and then augment those things with some flow tools and other things that I think could make a big difference. So I think we're going to see some things coming out at the June NAC that should be kind of interesting, and then we've got a summer's worth of analysis to do to make sure it's all feasible and realizable. But I think we're in a pretty good position, and maybe Mr. Tracy.
I was going to go to Tracy next. The
better.
The United Airlines of today has got a pretty big investment in the Northeast. Not that you didn't before, but it's grown. How are you feeling about all of this?
Well, I think it's not appropriate to say we can't do anything about weather. I think there are some things we can do. For instance, if one of the things we're talking about right now is trying to deconflict the New York airports, and to the extent we're able to do that, then perhaps weather will have less of an impact. And at Newark, for instance, if we can have a program with a 34 rate as opposed to a 30 rate, then we've got a lot less delay for the day, and we're going to cancel fewer flights, and that's good for customers.
Right.
I think it's all of those things, but to deconflict, I think New York needs more space. I think you've got to redesign the airspace, reconfigure it. I don't know whether you take some from Boston, some from the South, but you need to give those guys some place to go when inevitable they're, the decisions they have to make. You got to resize it, and that reconfiguration of the airspace is an essential component. You also have to look at the surface. Right. Because every system the capacity of the least component of that system. And if the capacity on the ground isn't there, you're not going to get the desired benefit. The other important thing in the Northeast is you absolutely must have an extremely robust program with the local communities to assess what it means, to describe what it means, and to engage them. That will absolutely fail if there's not a robust dialogue with the many jurisdictions that affect those decisions.
I think for many who have worked on these issues, they've learned that lesson about the New York community, so they're pretty adamant. Craig, how about you? How do you see trying to enhance their operations in the Northeast with the challenges they face there?
Well, first of all, the complexity of that area is incredible. This is not going to be an easy fix, and I don't think that we should think that it's going to be flip a switch and overnight it'll be there. It's going to take a lot of work and an awful lot of collaboration with a lot of people. One of the things that we haven't touched on surface is what happens during a snowstorm. Every airplane has to be de-iced, and that takes an extra 15 to 20 minutes at least. If you're operating at capacity already, it's like you're driving down a freeway, bumper to bumper, but everybody's doing 60 miles an hour, and all of a sudden somebody stops, and pretty soon everything gets backed up. And the same thing will happen, and so we have to figure out ways around that also. How do we handle that? How do we work with ATC on that to get these airplanes flowing quicker and making space for them?
Of course, Mark, General Aviation has this, in business aviation, this nice little community airport called Teterboro up there, which is one of the busiest in the nation. And so when you think deconfliction, you're thinking, how do you still operate and make sure you got entrance and exits from that airport?
Well, I think that's one of the questions that remains as we think about ATC reform, is the access to that airspace for business and general aviation. And what's happened around the rest of the world, that restriction to general aviation has inhibited freedom of that access. So that's what we're concerned about in the community. I think hopefully we can work that all out, where we can all use that airspace in the same ways we've been doing it in the past. But it's one of the concerns we have.
Well, and to the point Ginger was making about communities, and to the access point, the battle in Santa Monica, a place where I used to base an airplane, has been going on for decades, and it's not going well. It's not over, but it's not going well. So these are pretty public fights.
Well, shrinking that down to 3,500 feet from just under 5,000 is certainly going to change the complexion of the air traffic coming in and out of that aircraft or that area. But I think the opportunity we have now with a 12-year settlement is to go back out there and see if we can't work with the community and the surrounding areas, which has always been a challenge as it relates to development around that airport. Not really the airport itself, but at the end of the day, it inhibits traffic. So we've got to figure out how to solve that over time.
So I just want to follow up with what Craig just said. He picked the Icing Operations as a example. The key to getting to where Tracy wants to go, though, is how quickly will the information travel that says, we're going to move into de-icing operations right now, okay, for whatever conditions on the surface. That information now has to flow back to terminal and to en route, because what we want to do is not have everybody come crashing in and then bunch up, right? So quickly, we need to start scheduling people, or at least backing them up and taking delays in the en route airspace when we can, because we suddenly change the capacity constraint on the surface, right? And the more we can use information, it strategic information or your tactical information in a very strategic way to start balancing everything in the system, more quickly we'll get to the point where the called rate for an airport starts to make more sense and you can have more confidence in, because we know exactly what's going on right now and how long that condition might last. In which case, when will it be, when will that constraint be loosened? So those are the kind of things that we really have to look at as a community is, okay, how will we all use this information and how quickly, how granular is it? How, what's the word? How great is the quality of the information we're getting? And that means everybody in the system has to report what's going on and has to do it, with a lot of granularity and a lot of accuracy in order for the system to adjust rapidly. And I think we are going to be there with the technologies. The question is, how do we get there operationally? But I think we can get there.
Good. We have about 10 minutes left. I know you've been encouraged, I think, on the screens to send in a question. If you haven't, I want to get to some questions before we break, but I want to do one more thing with this panel that you can have, Adam, for a minute. You mentioned the word metrics, and I like that word too. One of the things I think that if somehow we could go back and do a few things a little differently, I would hope we would be smart enough to actually spend more time on metrics in the front end to really understand what people are going to be looking for when it comes to success, because I think we sometimes encouraged the FAA or made recommendations to the FAA that here are the priorities, do these things. And they did those things, but life didn't change sufficiently. And I came to two kind of conclusions about that. One, that we probably going in didn't fully appreciate what the key metrics were from different elements of the aviation community. And secondly, the different groups within the aviation community actually use different metrics to identify success. And that's not a bad thing. One's not right, one's not wrong. It's just different. But not being attentive to that, you could deliver on a recommendation but still be accused of not providing a benefit. So here's the little pop quiz. This panel's never going to work with me again. I didn't tell them about this either. Here's the pop quiz. If we invited you back a year from now, 12 months from now, and there was one metric or one or two, that had been achieved through this modernization process, what would it be? And I'm sorry, but I'm starting with you first. One or two metrics related to modernization that you'd like to see achieved in the course of the next year.
Reduction in delays.
By the way, repetition is good. That means agreement. Tracy.
Yeah, I think when you think about metrics, you have to start with what does the customer want. So completion factor comes to mind, cancel fewer flights, but I'll go with Ginger and phrase it as A0, arriving at the scheduled arrival time.
I'd like to see a way that we get adoption higher for ADS-B units in general aviation aircraft, and finding a long-term solution for datacom for general aviation as well.
Yeah, good. Carl?
I go with availability, just certainty that I'm going to arrive on time. And, yeah.
Great.
A0 with the reduction in block time.
Shrinking that block time. How much do you suppose?
What's that? You want to
How
know
much?
that?
I said he could have two. It's okay. How much? So let me probe this a bit. There's especially for the sophisticated airport operation. You've got better surface management. You've got better predictive capabilities for what's going to happen on the ground and en route. Better weather. We're working with weather. So how much? So when you say reduce it, give me a little more of a metric. What?
Well, I looked at some numbers here earlier today, and in 1990, between Las Vegas and Los Angeles, the block time has gone up 24% since then.
Right.
LaGuardia, DCA, it's gone up 19%. What was the other one we had? Houston, I think Dallas is up about 18%. And that's with 1990s technology. So why is it going up so much?
And the answer is?
I don't have the answer to all of that. But I would certainly
But
like
to
to know
reduce
that.
it, all these tools
should be working
should
together
be able to
bring
address
that block time down.
And not only is it bringing it down, but it's tightening that distribution. So it's making that bell curve steeper. And I'm sure you've all experienced it. That's why occasionally when I fly back to Chicago, sometimes I'm 30 minutes early. And that's because the
Right.
bell curve has
Well, that
gotten
was
so
my-
flat that we have to schedule it, way out here to make
Right.
sure that a sufficient number of people arrive on time. So I really think that's the huge leverage we've got in this whole effort.
Jim, metrics, is it still your favorite word?
Yes. And as the service provider, rather than me tell you what I think the metrics should be, I would tell you that if I advanced the clock a year and came back to this audience, I would like for the aviation community, no matter which 10 people I grabbed in the audience, they would all be able to tell me what metric they're interested in moving, why they're interested in moving that metric, what is the measurement baseline they're going to use to tell me whether or not there was a movement against that measurement or in that measurement baseline, and what was the measurement methodology that they thought actually represented the change in that metric. And I think the community is closing in on that, and I would encourage that is, in fact, the number one conversation to continue to have. Not to hold up progress, but I don't think we're quite there yet in terms of, I think there's a lot of right thinking about the things that people have asked for here. They are the things.
Right.
My concern is, do we have a consensus on how to measure those things, and what is the baseline that we measured against to determine that they're better, and what is the evidence that we're going to use? And if any 10 people that I poll, 9 out of 10 say that's what we're doing, then I think aviation's in a great place. So.
I agree with you, and I know Jim well enough to know that he absolutely means it, as do his colleagues at the FAA. And I guess I would, just to go back to that little point I was making earlier, I'd make the point that a year from now, but all through the year, the more candid you could be about the metrics you're looking for and whether they're getting hit or not getting hit, the better off we're going to be. I'm going to turn over to the voice of RTCA, Andy Sabula, who's been gathering, I think, a question or two.
Yeah, you've got a question or two, and I'm trying to relate them so you don't go too far off. But one of the things that hasn't been talked about yet is, and it's a big one when you start talking about the Northeast Corridor, is the issue of mixed equipage, and what are the perspectives on how you wrestle with that today and into the near term.
Okay, so you're going to be flying with mixed equipage or pretty much standard?
Well, we are for quite some time.
Right.
And that's certainly a question in my mind. Jim has helped me get my arms wrapped around the vision for where we're going eventually. But I'll tell you, it's not clear to me how we get from here to there and capture as much benefit as possible in that term in between.
Great, mixed equipment. Oh, you're going to have all this equipment.
We're going to be there October 1st. Similar to ADSB, I think that you just go ahead and set a date and shoot for it. You just make up you don't make up a date.
No,
but
right.
You certainly discuss it. If I was going to make it up, I'd say October 1st, but that's. But you have that discussion, and you bring all the parties in together, and you come up with a date, whether it's 2022, 25, whatever it is. And at that date, everybody has to be equipped properly.
I know Mark flies in Canada, and I know enough to know that even as good as the Canadian system is, they still have mixed equipage. They operate with mixed equipage, will continue to do so. So it's not like an end-all kind of a deal, but it probably doesn't get us to all the benefits we want, right?
That's right. It makes it a little more complicated, but there are ways to adopt. And if we wind up with best served, best equipped, it could take us backwards a while because there's just a lot of aircraft that don't have pathways.
Right. Good. One more?
Yep. So the one other one is, as you look at trying to evaluate competing priorities, how do you go about, or can you go about actually recommending things that the FAA should just stop doing?
So Jim, you've been there. How many things has the FAA stopped doing? I think there's always a constituency that gets built up around supporting whatever it is you are doing. But
I did get a letter about a VOR that was actually out of service for more than 2 years.
Right.
Decommissioned. So I'll just say that.
Okay.
No, it pretty much has to be the community coming forward to say what should be stopped. The FAA, and that better be a very strong consensus because, there's a lot of diverse users of the NAS, as we just talked about, and mixed equipage isn't going away. But let me circle back to that for a second, and let me tie mixed equipage with metrics, because one of the things that I've asked our own folks is, okay, we've got our PBN NAS navigation strategy, and one of the things we said was, well, if we give you a sort of picture of how well you could do if you equipped, ultimately we should be able to measure, right, how well we're doing. And if we could figure out, hey, we're not getting all the benefit we thought we would get, and if we could then show that that is a function of equipage, then maybe users would have the information they need to say, hey, we could get a lot more benefit if we put this equipment on board. Because I think a lot of people do, it's not always a direct connection in people's minds. I think it's great when it's possible to just get there and just say, hey, this is going to make a big deal difference. Datacom certainly has that ability to generate an immediate and instant recognition of a benefit. Navigation, it's more nuanced, I think, and it's going to take a little more convincing of everybody to go to the next level of equipage to do it. But I think if we can show in measurement that it is going to make a difference, and it's measurement plus simulation and other things that we have to do to convince ourselves, that's the difference. That's the thing that's holding us back now. We've done everything else, we've tried everything else, and we've measured everything else, and it's really, I think we'll be doing ourselves a pretty good favor in that regard too.
Thanks, Jim. Started on this side, we're ending on that side. Please thank a great panel for all the work they do with RTCA, the NAC. Thank you. Stay there for this.